Hey everybody, this is Larry, this is me going with Q2 of the Bible Giddy Contest 120, find Polygon with the largest perimeter. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this farm. So this one, to be honest, I messed up. I took 15 minutes on this one. I'm going to blame it on sleep, which is true. I only slept like an hour yesterday, and I'm going back to sleep after this, but still, this should have been a much easier problem. Now, of course, this is a greedy problem or a greedy solution. The solution is greedy, and of course, as a result, sometimes you have to prove or at least like have a good intuition about the proof, and I had neither. The case that I was thinking about was something like 1, 8, 9, 10 or something like this, and this is not a good case, but it's just a case that I was thinking about during the contest. I was like, oh, you cannot make 3 with these 3, but you can make 3 of these, right? So I was trying to figure out like how to handle these cases, and some of it is because I misread this as the number of the max number of sides and not perimeter. So I was like, oh, you could have a side 3 like this, but it actually turned out that it doesn't matter. But at the time that I was just trying to figure out like this property, and if you watch the live portion, I end up doing a binary search on the answer, and then realizing that's not what the problem is asking. So that's basically my Q2. But the idea here is actually if you change the question a little bit to add, like if you change it in a way to answer your question of. And my code doesn't really make sense for what I'm about to say, or maybe it does a little bit, but it's not how I would code it knowing what I know now. But the idea is that, okay, so let's say you have this array, and of course, let's say it is sorted, right? I don't know, maybe it doesn't have to be that array. I just add some extra funky stuff, right? Let's have this stuff, and then the question is, okay, you have to ask yourself is, okay, let's say you take a random number 15, and you ask, well, if this is the largest side, what is the polygon that could be made? And in this way, this is greedy, right? Because or maybe not ironically, but just like coincidentally, it is actually easier to have more sides because then now the sum of these, and if you look at this formula, they actually tell you the sum of these. Well, if you're looking for a sum of all the numbers smaller than 15, of course, like if 15 is the largest side, then you just want to sum up all the numbers, all the sides lower than 15, because you're always going to get a higher sum by adding more numbers, right? There's no negative sides, there's no negative number. So if you add more number, it's going to give you a bigger number. So as a result, then in a greedy way, if you have 15 and you want to add all the numbers previous to that, to get 15, and that's basically the idea, right? Is checking, okay, let's say I want a polygon of any number of sides and the longest side is 15, then what's the largest perimeter? Well, can you make a polygon where 15 is, can you make a polygon with all these sides? And of course, all these sides are a polygon if and all the smaller sides is, the sum of these is less than 15, or is greater than 15, right? So yeah, that's basically the idea, and if you do it that way, then it becomes much more straightforward. It just becomes a prefix sum essentially. You could sort, and then basically this is prefix sum. You sum the prefix of total. If the prefix is greater than x, then you can update this as your best. And actually, yeah, you always update anyway, because by definition of prefix sum, this is always going to be greater. So you could even just, for example, just write this. But yeah, but obviously during contests, I actually wouldn't think about it that much. This is free pretty much to do. So yeah, so that's pretty much it. That's why the greedy proof works. Being that you always just want all the smaller numbers according to it. And if you realize that, then you could probably get this very quickly. But yeah, this is going to be n log n for obvious reasons of that we do a sorting. Otherwise, everything else is straightforward. So it's going to be O of n log n and O of n space because of the sort. And yeah, that's what I have for this one. Let me know what you think. And you could watch me solve it live during the contest now. But that looks strange. Okay. Whew. That was a hoping for no typo situation. Say what? What happened to my pen? This is annoying, but okay, fine. People got it. This is such a weird problem. Wait, what are you doing, Larry? It's a little bit weird the way I'm writing it. That's not good. Oh, I messed up. I did the longest length, longest number of sides, not the length. How do I fix this? Why am I spending so long on Q2? I misunderstood it. Okay. How do I fix? How do I fix? I have to rewrite a new problem. Maybe I should have just slept. I am so not in shape right now. How am I doing it? 24. How do I get 24? 2, 4, 7, 12. Man, I do not know how to solve this. And also, I'm wrong on how I want to do it. Just this. Am I complicating things? It is. I complicated that one. Overcomplicated as well. This is go 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 go. What it? Already starting off weak. But let's go. Uh-oh, that seems like it's gonna be on like Q4 or something. But it is such bad code, but gotta get it done quick. $10.7 to be. But that looks strange. Okay, whew. That was hoping for no type.